Hi, I'm Karthik Rannan. I'm the president of the Wall Street Club of BITS Pilani Hyderabad campus. Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives while they try to navigate the world of finance. I am happy that we will be able to close this workshop successfully on a very good note.
Hi, I am Raghunendra Singh and I am the Technical Director of the Wall Street Club at BITS Pilani Hyderabad campus. It was a great amazing conducting this workshop with XLR. The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets, which was very helpful for the people who are interested in the field of finance, business or analytics in general. Thank you.
I attended a workshop conducted by CSA and ACM in collaboration with XLR. So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
The journey was great. Initially, I thought that I was not proficient enough in Excel, but later I came to know there was no prerequisites for it, and then I applied for it, and it was a great course, and it started from basics and took me to a great extent.
Good evening, myself Kavya Ganatra. I am from Computer Science Association. I was the POC for this ML workshop conducted by CSI and ACM in collaboration with XLR. The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our technical fest Atmos, and I thank XLR for being a part of it. Thank you.
everyone. My name is Tasneem. I'm the senior manager at 98 percentile in the HR department. And today we did a wonderful drive with XLR. It was amazing right from the very beginning, from the very first day when I got in touch with them till today. I think it was an extremely smooth journey with them. There were multiple follow-ups done by the representatives in order to check that we would be, what time we would be coming, how many people would be coming, what vehicle we would get. To that extent, they were so precise in giving all the information to us. It was extremely great to get associated with them and have a drive at XLR campus. So we are very, very happy that we got a chance to do this. Now, coming to the students, what XLR had, I think they were extremely enthusiastic. They were well prepared. They were aware of what they are coming for. I think there was some back-end preparation which they did that was commendable. They also were very confident and they were open to any kind of thing we were asking them to do. That was I think the best part. Now, I really hope we have a very, very fruitful association with each one of them and XLR in future. We are really looking forward to have many more drives like this.
Hi everyone, my name is Prachi Sharma and I'm the Senior Project Manager for IT Department at 90th Percentile. So today we were here for this IT bootcamp, right, this technical drive and at XLR. So it was a great experience and I would feel that the students, they are the freshers, right, but it doesn't seem like that. So if I talk about their technical and cognitive ability, they all seems pretty good in that and that's what I felt. And I guess they have been taught pretty well at XLR, so that's how they have performed good in their aptitude and the technical tests. So I wish them all the best and it was a very great experience over here.
Hi, this is Patan, Technology Consulting Manager from 98th Percentile. We visited XLR for the campus placement drive and it went very well today. Miss Ambika, Miss Pragati, everyone received us greatly here and we had a lot of enjoyable time here. The students even had great experience with us. They were interactive, they had good aptitude and all the technological skills they showed. I think they were all well and we really appreciate their time that they spared to us and I think we will be doing a great job. We are expecting a lot of people to be hired from them. Let's see. it was a great experience altogether.
Thank you.
Thank you so much.
From entering into the cyber tower to exiting out of this tower, the XLR team has been received me with such a care and pleasure.
I am the part of this XLR since 4 months. From the third month itself, they have conducted the placement sessions from the third month itself, and this is the fourth month, and this is the 98th percentile is one of the placement drive I have attended so far, and attending to this drive is such a good experience for me. All the HRs and the team made us feel very comfortable and confident.
XLR helped me a lot, and I experienced a lot of things today. So I'm really hope to be placed in that company. I'm confident about that. Thank you.
Am I audible to all of you guys? Okay, great. So let me share my screen. Guys, is my screen is visible? This Python notebook? Okay. Thanks. Okay. So let's begin with the session, guys. So till last class, guys, any doubt or any queries? Anyone? Any doubt, guys? Any queries till last session? Okay, cool. So today we are going to see, guys, another application of the NLP, that is the text classification. Okay. And this Python notebook and the data set and all for today's session will be available over the LMS portal. You can download it and use it parallelly if you want. Right? So let's first understand, guys, what is a text classification? Anyone, guys, any idea what is a text classification? Anyone? Any idea what is a text classification? Categorizing the text in any one group. Exactly, Nandini. Yes, correct. So yeah, it's correct. So actually text classification is nothing but, guys, if you have a multiple documents, so let's say this is a document 1 D1, you have another document 2 D2, you have another document 3 D3, and so on. Let's say you have n number of documents, and these documents belongs to different let's say different topics or different kind of what you can say sentiment is there, or different topics is there, or different departments these documents belongs to. So just group the like these documents, like similar kind of documents into one group. That is something called as a document clustering. But here we are doing the text classification. That means we will classify like this document one belongs to which of the group. So let's say let's say we have two groups, group 0 and group 1. So whether this document 1 belongs to group 0 or group 1, right? Let's say document 1 belongs to group 0, document 2 belongs to group 1. So like this kind of a classification we do for each and every document. And when I say the document, guys, please remember we have two terms, document and corpus, right? Document is each and every individual review or feedback or tweets what we are getting from the different users. And collection of all the tweets or feedback is something called as a corpus, right? So that means each and every review or tweet we are classifying into one of the group. So these, like how many groups we have, this is something predefined. So we already know how many groups we have, and we classify the document into one of those groups, right? This is something we are calling as a text classification. Okay. So before proceeding with this notebook, let me also show you the data set. Is this Excel file is visible, guys? Okay, great. So guys, this is a like tweets data set. I mean, this data set we have downloaded from the Twitter, and this data set belongs to like COVID time data set. So we have a tweets related to coronavirus, right? Okay, yeah, cool. So we have a tweets related to coronavirus. So if you see what are the features are there, username, that is nothing but the it's just a indexing kind of thing. Screen name, it is a unique, you can say IDs provided to each and every user. Then what is the location of the user? So like Melbourne or Los Angeles, Geneva, New Delhi, USA, Bangalore, and all US, Canada, like that. So what was the location of the customer or the user? And then what was the date, right? And then we have a variable called as a tweet. So what was the tweet made by the user? And then we have a like our final variable, which is a class. So this class variable contains the values either 0, 1, or 2. That means this class variable is classifying each and every document either one of the classes, right? So if you see the first tweet, which is this one, this tweet is being classified into one of the classes as 2, right? Second tweet is classified into a class 1. So likewise, we have a 3 classes, class 0, class 1, and class 2. Now, the interpretation of these classes is actually, this classes interprets like what is the sentiment of the tweet related to coronavirus. So if the particular document or tweet is classified as a class 0, that means the sentiment is neutral. If the particular tweet is classified as a class 1, that means it has a positive sentiment. And if the tweet is classified as class 2, it has a negative sentiment. So this is the interpretation of these classes, right? So we already have this kind of a data set where we have the tweets related to coronavirus, and we already know like which tweet belongs to which class, right? Now, based upon this data set, we are going to build a model that will classify the future tweets into one of these classes, right? So let's say we build the model over this data set. And what this model will do, this model will do the prediction for the future tweets. So after building a model, in future, if I get a tweet related to coronavirus, I can directly pass this tweet to my model, and my model will predict like this document or this tweet belongs to which class. So for model building purpose, we have some past data, and this is our past data. All right? Is that clear, guys? What we are going to do? Any questions, anyone? Okay. So apart from that, guys, just by looking this tweets, can you guys tell me like what are the abnormalities present in these, this tweet variable or these documents, whatever we have? Can you guys identify some of the abnormalities which we can remove using the text data pre-processing part? Special characters, yes, correct. What else? Yeah, special character is there. Yes. Anything else, guys? Stop words. Yeah, Kritika. Great. Stop words is also there. Okay, let me. Okay, so one more. Speech. What is speech? Anyways, so guys, you can see here. Okay, one more. Let me see. Okay. So if you see, guys, one of the abnormalities basically we have a lot of special characters, right? Like hash, and most of the times we have a hash, or you can see this question mark or explanatory signs, right? And this brackets and all. So a lot of special characters are there. Ampersand, like this, semicolon, right? Question mark. Apart from that, if you see, sometimes we have a URL present like this. All right. So few of the documents contains the URL part. Apart from that, few of the documents contains the Twitter handle like this. This is the Twitter handle, right? Or this one. This is the Twitter handle. Since it is a tweets data, right? This one is a Twitter handle. And we have a hashtags, right? These are the couple of hashtags. Couple of words are in capital letters and couple of them in small letters, right? So there is an abnormality like this. So we have a lot of abnormality present in this tweets variable, all right? So let's see, guys, how we can clean this data set and how we can build a text classification model. But this time, I'm not going to use whatever text pre-processing steps whatever method we saw for a text data pre-processing. We are going to use another a very new library, not very new library, but I haven't discussed this particular library earlier. So first time I'm going to introduce this particular library so that you can perform number of tasks for a text data pre-processing part. All right. So the name of the library is actually neat text. Neat text. This is the library name what we have, and within this library we have a number of functions are there or methods are there, so that you can clean your data in a very easy manner. All right. And then rest of the variables like username, screen name, location, tweet at, these are not important for our model. So our focus will be on this tweet variable and the class variable to build the text classification model. Is that clear, guys? Any doubt, anyone? And this data set and the Python notebook is available over the LMS portal, guys. I guess under the day 6, we have this one. So you can download it and use it. Yeah, Andrew, correct. Yes. So from a broader aspect, location is one of the important feature, right? But for our case, just to illustrate you what is a text classification and how you can build the things. So we are going to, take this tweet and class variable. But from a broader perspective, yes, you are correct. Location is one of the important factor. Okay. So let's come to this Zipton notebook. So here I have mentioned that what we are going to do. We are classifying the text either positive, negative, or neutral emotions or sentiments. All right. So whenever we have a class 0, that means the sentiment is a neutral. Class 1, positive sentiment. Class 2, negative sentiment. All right. And then we are just importing couple of required, methods or, libraries and all. So matplotlib and seaborn, these are for visualization purpose. Pandas and NumPy, you guys know. And then from sklearn, we are importing something called as a logistic regression. So I will come back to all of these things. What is a logistic regression and what is a multinomial Naibes, multinomial NB and all. Right. We are also importing from sklearn.matrix as an accuracy score to test the accuracy of our model. Right. Train test split. This is something from sklearn.model selection. We have something called as a train test split. So we'll discuss like these things in a couple of minutes, right? And you guys know what is a count vectorizer and TF-IDF vectorizer. Okay, guys. The NLP pipeline will be the exactly same. So what is the pipeline? So we have an input data. That is nothing but this tweets data, corona tweets data. Over this input text data, we have to apply the text data preprocessing. Right? And then after text data preprocessing, still we are getting the text data. That is a clean text data. Then to convert this text data into the numerical form, we have to apply something called as a vectorization. And then once we get the vector equivalent of our text data, then we can apply any of the model or statistical technique. And then we can get the final outcome. So this pipeline will be exactly same, guys. But this time, whatever text data preprocessing methods we saw, like from the implementation point of view, the concept will be the same, like converting into the lowercase or removing the stop words, right? Removing the special characters and all, punctuations and all of those things will be the same, but the method will be different, right? Okay, let's start. So first of all, guys, I am just importing my data set. It is a corona tweets.csv file. And you can see here, like these are the variables. So username, screen name, location, tweet at, the date, as well as the what is the tweet. That means that each and every document and the respective class, right? And the class denotes that the sentiment or emotion. Okay. And since our focus is on the tweet and class variable, so this is how we are just, taking the tweet and class variable. And this is our the data set over which we are going to work upon, like the tweet and class variable. All right. And you can see a lot of abnormalities there in this tweet variable. So like tweets may contain some, some kind of headings kind of thing like trending and all. Some hashtags are there. We also saw like a lot of special characters, and sometimes we have a URLs and all. So let's see, guys, how we can handle all of those things. Even not only this, if in future, if you guys are getting emojis in your text data, emojis, I'm sure you guys know what is the emojis, right? If you guys are getting the emojis, that is something also you can remove from your text data, right? Yes. Okay, let's see. So in total, guys, we have a 2000 plus tweets, and there are two variables. That's why the shape is 2158. These many tweets or documents we have with two variable. One is a tweet, one is a class, right? And if you apply the value counts over your class variable, so can you guys tell me what these numbers denote? How would you interpret this output? Anyone? How you will, interpret this output of value counts over the class variable? Exactly, Nandini. Yes, correct. So in our data set, how many number of records are with class 1? So that means out of 2158 documents or tweets, 947 tweets belongs to class 1, 619 records belongs to class 0, and 592 records belongs to class 2. So, I mean, these many documents, like out of total documents, this is a segregation, how many documents we have for each and every class. Even you can also, visualize how many documents we have for each and every class using the bar plot. So we are just, taking this outcome like df of class dot value underscore counts, this particular outcome, and over this outcome, we are just plotting a bar plot. So how the bar plot looks like this, right? So from this bar plot, you can visualize your text data. Like for class 1, we have around 947 documents. For class 0, around 619 documents. And rest of the documents for class 2. So this is how you also get the visualization. Right? Okay. So let's come to the text pre-processing part and how we can clean our text with a package called as a neat text. Right? So this is the package what we are going to use, and this is a very powerful package, guys. All right? Okay. So this is one of the glimpse like what tweets we have in our data set. So let's see, guys, what we can do. So here I have just displayed the first tweet what we have. I'm sure you guys understand the this particular syntax of ilog of 0. That means the first tweet, very first tweet what we have. Yes. So this is the very first tweet what we have trending, and then this is the tweet starts. New Yorker, encountered empty supermarket shelves and all, and then at the last we have a one URL, right? And in between we have this hashtag kind of a thing, along with some special characters. So this is the first tweet what we have in our document, right? Now let's see, guys, how we can use the neat text as a package and how it works. So first of all, guys, you need to install this particular package, right? So since I have already installed, so what you guys can do, just remove this hash sign and install this particular package, right? And guys, installation of the package is one-time process, right? No need to install it again and again. Installation is a one-time process. Import is something what you need to do again and again, right? So let's say after today's session, tomorrow, if you open the notebook, then no need to install the same package. You need to just import the package. Okay. So since I have already, installed this particular library, so I'm not going to run this line number 14, what you're seeing. So from the neat text, actually, we are importing two things. First one is a neat text as an NT. It is also useful. And under the neat text, we have a one module as a functions. This is very powerful module. So we are just importing this module as NFX. And within this NFX, which is a neat text.functions module, we have a lot of methods and functions, right? But apart from that, if you want to check what is the version of your neat text, so like this is how you can check the version, right? Even you can, like in this method, you can check version of any of the package. So like package name dot double underscore version double underscore. So this is how you can check the version of any of your package installed, right? Okay. So now let's have a look. What are the methods are there in this neat text dot functions module, which is a NFX. So please remember this, short name like NFX stands for the neat text functions and T stands for the neat text. Okay. So these are the, directory of the NFX function. So we have a lot of functions, like we have a couple of functions related to regex. So regex is something, guys, it stands for the regular expression. Regular expression. This is one of the what you can say method we have in NLP through which you can identify patterns in your data set. If there are certain patterns present, or if you want to fetch or identify, some patterns, or if you want to detect the patterns. So these kind of things we do with the help of something called as a regex or regular expression. All right. So with respect to regex, we have a couple of functions. You can see there is a one function called emoji regex. So if there is some patterns related to emojis in your data set, that is also you can identify and detect or fetch from your input data set. Right. So likewise, if there is a pattern in the numbers, so that is also you can detect and fetch. So this regex is something where you have a patterns present in your text data and you want to detect or fetch. Apart from that, guys, we have something called as a stop words. So stop words in different languages. So you can see stop words underscore en. En stands for the English language stop words. So likewise, we have a stop words in different languages. Using this particular function, we can directly remove the stop words. All right. And if you just scroll it down, this is something, guys, I have explained in earlier classes. The functions which starts from double underscore and ends with the double underscore. These are the function which you can't use like this up to this part. These are the functions which is for a developer, a person, or the person who is doing some kind of a research kind of thing, right? So for them, we have this kind of a functions. So we as a user can't use these functions. Okay. If you just scroll it down, here you can see we have a lot of other functions like extract dates. If the dates is there in your data set, you can extract those dates, all of the dates from your corpus. You can even extract the email IDs if there is any. You can extract the emojis. You can extract the hashtags if there is present. Like in our case, we have a hashtags. You can even extract the HTML tags if there is any, numbers, some patterns, phone numbers, short words, stop words you can extract. Guys, this is the extract method. This is not the removal method. It will just extract those things and give you as an output. It will not remove these things from your text data, right? This is the extract methods, right? And if you just scroll it down, here you can see the remove methods. Now, these are the methods, if you apply over a text data, they can remove these abnormalities. Like if there is any currency is present, like remove underscore currency, this is the method. You can remove the currency. You can even remove, some custom words. Like if you want to remove some particular word, you can specify remove this particular word. It will remove those words. You can remove the dates. You can remove the email IDs. You can remove the emojis if there is any, hashtags, right? Numbers. So these things, it will directly remove from your text data. Like stop words, we can remove the stop words. You can remove the URLs. If there is any user handle, just like in our case, we have a Twitter handle. That is also you can remove it. So I mean, lot of functions and functionalities are there in this particular package called neat text.functions module. All right. You can even count the word frequency, word length frequency. This is something we have some extra functions. So these many functions are there, guys, in this particular package. Let's see how we can use this. Okay. So first of all, let me just show you a couple of functions how we can apply. Then we will show you how can we proceed it. So let's say, guys, this is my tweet data. These are the different tweets what we have, and I want to remove the stop words. I want to remove the stop words. Like if you see in the second tweet, we have a I couldn't, right? And if you see, even empty is one of the stop word, or this the right? The of. So these are a couple of stop words in. So I want to remove these stop words. So one of the method is what we have already saw in past sessions. That is one of the method. Or you can directly use something called, so over this tweet variable, I'm applying nfx dot remove underscore stop word method. It's very simple. Just apply nfx, that's a neat text function, dot remove stop words. Stop word is a method. And we all know how we can use the method using the dot operator. That's why we have a dot here. And if you see the outcome, so from the first tweet, if you see, it removes the empty. So empty is a stop word which is present in this particular list. For the second tweet, if you see, when I couldn't, these are the stop words. So these are removed and it starts with the find hand sanitizer and all. All right. At is a stop word. It is removed. So likewise, it will remove the stop word directly from your input text data. Right. Let me also show you another example. Let's say I want to remove some, this user handles. So this is a Twitter data, Twitter twist data. So we have a Twitter handle. So this is one of the Twitter handle what we have. This is again a Twitter handle at the rate, right? Or okay, so here we have only these two. Let's see. So to remove the user handles, so over the tweet data, just apply nfx dot remove underscore user handles. Now, if you see, for this particular tweet, 2156 tweet number. So over this tweet, now it removes the user handle like at the rate this one and at the rate this one. So after the economics, we have a was on talking. Right? So I mean, this is how you can apply different functions over your input text data and get the clean text data. Right? So this is what I've showed you guys. This is, I mean, just applying the method and getting the output. I'm not saving this result, right? I'm not saving this result into a new variable. I'm just applying the method and just to show you the output. Even you can apply more than one method at a time. So let's say I want to apply the stop word and user handle both together. So this is also you can perform like this. What we are doing over the tweet variable, first we are applying the remove the user handles if there is any. And then whatever is the outcome, like this is the outcome of the removing the user handles. Over this outcome, apply the removing stop words method. So now in this outcome, you can see the user handle is also removed. Along with that, it removes the stop words. Right? Is that clear, guys? How it's working? Any questions, anyone, up to this part? Okay, let me also check with YouTube, guys. Great. So let me share my screen. Okay, guys. So if this part is clear, let's say a couple of more operations. Right. Okay, let's see how you can remove the hashtags. Right. And this is something I'm showing you, taking one of the tweet. Right. So this particular example, what I showed you, taking over the all the tweet, like all the tweets, that is taking the complete corpus. But let's see if you want to apply, these of the methods over a particular tweet or a particular document, right? This is also you can do. So what we are going to do here, we want to remove the hashtags. So only for, let's say, a particular tweet, and that is a tweet number 2. So this is the index position, right? This is the index position. So index should start from 0 and then 1. So index 1 means it is the second tweet. So in the first part, we are just printing the second tweet, whatever tweet we have, and this is the original tweet what we have. So you can see here, when I couldn't find hand sanitizer at Fred Meyer, I turned to hashtag Amazon. This is one of the hashtag what we have. And then we have, this much information, and then hashtag coronavirus. This is the second hashtag what we have, this one. Okay, so there are 2 hashtags are there. So to remove the hashtag over a particular tweet, we can use something called as nfx.remove_hashtags. And within that function, you need to pass a particular document from your, tweet variable. So if you want to apply a method over a complete, like over a particular variable, like tweet variable overall, then use the upper methods. If you want to apply this method over a particular document from your column, so you can use this kind of a approach. Now, when you apply the remove_hashtag method, so what is the outcome? The outcome is this. So now you can see, I turn to hashtag Amazon. So hashtag Amazon, this particular hashtag is removed. So I turn to, then we have a nothing. And then check out how hashtag coronavirus, that coronavirus is something is removed. So I mean, in that way, you can even remove the hashtags if you want, right? If you want to remove the user handles, so let me just show you. So this is the, tweet number, like the index position is a 2156. So here we have a 2 user handles, like this is one of the user handle. This is another user handle. So you can even remove the user handles using the same method over a particular document. So nfx.remove_user handles and just provide the a particular document what you have with the index position. And you can see here the output is this one. So it will remove these user handles. So assistant professor of economics, and then we don't have this user handle was on. We don't have this user handle talking about her recent research on coronavirus, like that. So I mean, this is how you can apply multiple functions from neat text module and get a neat and clean text as output, right? Now let's proceed. So this is what I have included as an example. Here also we can use more than one function on a single document. Yes, but this time, I mean, what you need to do, you need to save this outcome, and then you can again apply that. So over a particular document is something you have to apply one method at a time. All right. Okay. So let's proceed, guys. What we can do. Okay, let me also show you one thing. If you want to remove a particular pattern, I mean, let's say, let me show you from here. Yeah. This is our original tweet, guys. This one. This is our original tweet variable. Let's say I want to remove a particular pattern. You can specify what is the pattern. So let's say I want to remove if there is any trending kind of a word is there. So this is one of the pattern which I am providing. If this kind of a thing, it founds anywhere over this, this corpus, just remove that. Because this is something I don't want. This is a not part of your tweet, right? So this is also you can do with the help of remove custom patterns, right? So here what I'm doing, I'm applying this nfx.remove custom patterns, and over here I'm specifying what is my pattern. So the pattern is trending colon. So whenever it finds a trending colon, it will remove this part over my tweet variable. And whatever is the output, that output I'm saving into a new variable called df clean tweets. df of clean tweet. So clean tweet is the new variable over which I'm saving the outcome of this operation. And now if you see df of clean tweet, in my first document, initially I had this trending kind of a pattern. Now this pattern is removed. So whenever over this corpus, it finds this pattern, it remove that one, right? And then like whatever methods we have discussed. Okay, so let me also show you how you can extract the things. So let's say I want to extract the user handles. Guys, this is the extract method. This is not a removal method. So removal is this one, like remove or remove hashtag. So it will remove. If you want to extract something, you can also do that. So we have a something called as a nfx.extract_user handles. So what it will do, it will not remove the hashtags. It will just extract the whatever user handle is present in your corpus. And I'm just applying this particular method using the lambda function over my clean tweet variable. So this clean tweet variable we have just created from the above step. All right, over the clean tweet, I'm just fetching the user handle and I'm providing a column name as a user handles. So over this column name, all of the user handles is being saved. So you can see here the document which contains the user handle. For them, we are getting the user handles. All right. So I mean, this is how you can even extract some of the features or patterns from your data set. So, but this this user handles are they are no use in our model building part. So what we are doing, we are just removing these user handles, same using the lambda function over this clean tweet feature, and whatever output we are getting after removing these user handles, I'm saving the the clean text data into the same variable clean tweet. So this is what we are getting. So this is the clean data what we are getting after removing the user handles and removing a custom pattern, which is the trendy. So up to this point, we have just removed these two things, any custom pattern like this trending one, or if there is any user handles there. So these are the two things we have done up to this point, and we have saved the outcome into a new variable called clean tweet. So up to this point, guys, clear? And any questions, anyone? What about YouTube, guys? Okay, user handler. Okay, I'm repeating it again. Great, Anila. So let me repeat this user handle part. Okay. So what is this user handle, guys? This user handle is nothing but it is the, since we are dealing with the Twitter data, so it is nothing but the Twitter handle. I'm sure you guys know what is a Twitter handle, right? It starts with the @ the name of the person, right? Or whatever, like whatever name you have mentioned in your account. So like that. So this is something called as a user handle. So it is specific to the social media platform. For Twitter, we have something called as a @ name of the Twitter handle or whatever is the account we have. So for different users, yeah. So for different users, we have a different Twitter handles. So this is the Twitter handle what we are getting in this like in this Twitter data, and we need to extract and you can remove this user handles because this particular text data is containing nothing. I mean, there is no information present in this text data while it comes to the when it comes to the classification part. So this is just the name of the account, like Twitter account kind of thing. So what we are doing under the neattext.functions module, we have a method called extract user handle. If you want, you can extract this user handles name or Twitter handles name, or you can directly remove these user handles like this. So if you see let me take an example of this particular document 2156. So here you can say this is the original 2156 document where we have a assistant professor of economics at the rate this one was on at the rate the second Twitter handle. So these two Twitter handles is fetched using this extract underscore user handle method. So it will just extract the user handle or the Twitter handle, whatever is present in the text data. And the second method what we have applied, remove this user handles, right? So what it will do, it will remove this part and this part because these two are the user handles. So whatever is left, assistant professor of economics and then was on and then the next part. So this is what we are getting as an outcome of a remove user handle. If you see 2156, assistant professor of economics, then we don't have a user handle, was on, we don't have a user handle talking about something. So in this place, we have a space only, right? This is the double space what we have. What is lambda function for? Is it the syntax? Yes. So actually, lambda function is one of the concept in Python, right? It is a short form how you can apply a particular method. It is called as an anonymous function. So alternative to this, you can create a user-defined function and use this particular method. So rather than writing couple of lines to create a function, what we can do, we can use the lambda function, which is an anonymous function, and we can directly use like this whatever method you want to apply. So this x is a this one is a variable, and in this case it is nothing but each and every document. So for each and every x, apply this particular method. So this x is a each and every document present in this clean tweet variable. All right, and this lambda is a keyword. It is a keyword. It is called as a lambda function or anonymous function. Okay, clear, guys? Okay, let me also show you. Let me also show you one more like very interesting library, and that is called as a contraction. Contraction is a library, guys. First of all, you need to install this particular package. So like since I have already installed. So what you can do, you can remove this hash sign and then install it. Then we are importing this particular package called contraction. This particular module is useful when you want to expand the terms like this one. Let's say couldn't. So if you want to expand it like could not, right? Or shouldn't to should not, or I am. So you can expand this I am. So if you want to just expand this contracted word, you can use a library called contraction, right? Let me just show you with one of the example. So we have imported this contraction. Within this, we have a function called fix. And within this function, if you pass any of the contracted word like I am, so it will, expand this word as a I am. This is a utility of this particular module, right? So I have included this part just to show you the functionality of this particular module, right? So let me also apply this particular contraction thing. So under the NFX, we have something called as a fixed underscore contraction, right? We already have this contraction method, but just to show you what is contraction, I have installed this particular library and showed you through an example. And if you apply nfx.fix underscore contraction module over all of your tweets in the clean tweet variable, now you can see instead of couldn't, I have a could not, right? And at this particular place, I have just applied this method, but I'm not saving this result. So this is what I'm doing in the next line. That is the exactly same thing. I'm applying this particular method using the lambda function, and then whatever is the result, that means this one, I'm saving into a same variable clean tweet, right? So this is how you can apply fixed contraction method. And what it will do, it will just expand this contracted word, like couldn't to could not, shouldn't to should not, am to I am, right? These things it will perform. Then you can also, remove the special characters. Whatever special characters we have a lot of special characters present in our this tweet data. So you can see here we have a hashtag kind of a thing, or dollar kind of a thing, or this hyphen kind of a thing, right? This hashtag kind of thing what we have. So you can remove these special characters. So the method is like remove underscore special underscore characters for each of the document present in this clean tweet variable. And if you see the output, so like instead of $2.99, now I have only 299. It will remove this dot operator also, right? Instead of having this equals to, I have a space here. So this is another way how you can remove the special character, that is nothing but the punctuations. We already saw one or two methods how you can remove the punctuations in our previous sessions. This is another way, right? And then you can also remove if you have a multiple spaces, right? So if you see here, from this 2156, we have removed something called as a user handle. But after removing the user handle, we have a double space here, like at this place. So it will create an abnormality. So if there is any multiple spaces are there, just remove those multiple spaces and convert into a single space, so that there will be a uniformity across all the documents. That is something we can do with the help of nfx.remove multiple spaces module. So this particular method, it will go through all the documents, all the tweets over this clean tweet variable, and whenever it finds more than one spaces, it will just ignore those spaces, it will just remove those spaces and convert into a single space, right? So if you see the same 2156, now after the economics, we have only single space, was on a single space, right? So it will create a uniformity across all the documents in terms of the space. Okay, Anurup, the question is 2.99 is completely different from 299. So actually whatever operations we are going to perform here, so what we are going to do here, we are going to build a text classification model. For our purpose, the numerical data is of no use, right? So it depends upon like what actually you want to do with your text data. Okay. But let's say in future you want to extract the price which is present in our text data, then we don't apply this kind of operation. Otherwise, the price details will get changed. So as per the need, we adopt these methods, right? Okay. For example, let's suppose in future there is a requirement to extract these hashtags, or let's say this user handle. And if you are randomly using the method called remove user handles, so it will remove all the user handles. You won't be able to extract anymore after this. So it depends upon like what is the need, what you want to perform. Okay, yeah, great. Clear, guys? Any questions up to this part? Anyone? YouTube guys, any questions? Divya, use of the lambda function is nothing but I'm sure you guys know, in different languages, sometimes we need to write our own function. That is something called the user-defined function. So in Python, we have a facility. Instead of writing the user-defined function, you can use the lambda as an anonymous function. right? So if you start writing your own function for a simple task, it will take around 4 to 5 lines or 6 to 7 lines to write the complete function. So instead of writing this 6 to 7 lines of code, you can just write half of the line like this lambda function syntax, and you can perform the same operation, right? For example, let me show you. Okay, so let me show you from here. Okay, so let's say I want to remove this user handles, right? Now, if I don't write this lambda function here, then what I need to write? I need to create a function, like in the Python function, it starts from the def, then the name of the function. And then from here, first of all, I need to, I need to apply the for loop for each and every document for I in range of length of this particular document. And then for each and every, value of the I need to use this kind of a method. So, I mean, it will take, 5 to 6 or 7 lines of code to write it. And then, we have to take care about the syntax also, along with the, the orientation kind of thing. So, instead of doing this kind of a task, what we can do, we have an alternative as a lambda function. So, if it is just half of the line only. So this is just like a user-defined function, or you can say the loop kind of thing. It is an alternative to the loop, what we can do here. And this is a syntax, like lambda is a keyword, x is the variable. So in our case, x is nothing, but it is each and every document for this clean tweet variable. And this colon is a part of a syntax, and then apply the method over this x. Right? This is how we have a lambda function. Okay. Any other questions, guys? YouTube guys? So, Kritika, if you're facing any doubt, or if you're stuck anywhere, while implementing the things, so what you can do, you can, write down your doubt over the chat box, and I will take it. Okay. Okay, guys, cool. So let me share my screen. Okay, so this is what we have discussed. Couple of a text data pre-processing part up to the removing of the multiple spaces. Okay. And then we have a something called as a noise scan is one of the method under the NT. NT is a neat text frame, noise scan and text noise, something like that. So basically this is nothing but it will show you, it will give some score, and this score will tell you how much abnormality is present in your document. Like for each and every document, it will generate some kind of a score, and it will tell you like how much abnormality is there. So this is how you can identify whether there is any scope to further clean your text data or not, right? Even you can remove the stop words using the neat text function module. So we have a remove stop words, and the language is the English, right? Over all the x is nothing but each and every document over the clean tweets. So this is how you can even remove the stop words, right? And this is the last data pre-processing method what we are applying, and whatever result we are getting, we are saving into a new variable called corpus. So this will be my new corpus where we have a clean text data, right? Where we have a clean text data. Okay. Now we are just doing some kind of a EDA process here. What we are doing, since in our corpus we have each and every document which is a segregated, like each and every document is a separate, right? So what we are doing, we are just joining each and every corpus and then splitting based upon the space. So what we are getting, the each and individual word, and then we are just finding the word with the most frequency and give me top 30 words. That means what are the top 30 words with the highest frequency in my data set? I mean, in this corpus data set. And what is the other method, guys? How you can visualize this one? Do you guys remember the word cloud? Word cloud is another method from where you can get the most frequent word in our text document as a visualization, right? But yeah, here we are just printing top 30 most frequent words with their frequency. So you can see here, COVID-19 is the most frequent word with a frequency as a 1298. Then coronavirus 759. Food 716. So this number is the frequency term. How many number of times this particular word is used in this corpus dataset? Okay, so Nandini, this is nothing but what we are doing. From the collections module, we are just importing a method called counter. This counter method, what will do? It will just provide you for each and every word what is the frequency of the word. And how we are getting the frequency? So let's say, for example, let's say I have this particular tweet, this one. So until unless I will get the each and every word as an individual, it won't get the frequency. So as of now, it is a single document. So what we are doing, first of all, we are just splitting each and every document with the space. So when you split each and every document with the space, what it will do, it will just separate each and every word. So new is a one word. Second word is a Yorker. Yorkers. Then encounter is another word. Empty is another word, like that. So once it gets these individual words, then this counter method, whatever this counter method we are using, it will calculate the frequency of each and every word in this corpus dataset. And this is what we are just printing. We are printing the most common 30 words. So it will give you top 30 words which is having the highest frequency. So COVID-19 is a word which is present in this corpus that is having the frequency count as a 1298. Then the second highest frequent word is a coronavirus in this corpus dataset. So 759 is a frequency count. So likewise, we are getting the top 30 words with the highest frequency. Is that clear? Yeah. And then we are just visualizing, this thing using a bar plot. So this is something we are calling as a EDA part, exploratory data analysis in NLP or in text data, in text mining, right? You can visualize like this kind of statistics using different kind of plots or graphs from our text data, right? Okay. And also you can do something called as a word cloud. I'm sure you guys remember what is a word cloud, right? So what we are doing first of all, we are just joining each and every document and we are preparing a one single paragraph. So this paragraph is nothing but it contains all of the documents, right? We have just joined all of the documents from the corpus module. And then over this paragraph, we are just, plotting the word cloud. We are just visualizing this word cloud. And this is how you can see here, right? So you can see here, COVID-19 is a word which is having the highest, or you can say the largest font size. So what is the concept here? The largest the font size, higher the frequency. Larger the font size, higher the frequency. And accordingly, we are getting this word cloud. Is that clear, guys, up to this part? YouTube guys, any questions? Yes, RV, a lambda function is also called as the anonymous function. Okay, guys, let me share my screen. Kritika, the conclusion of these plots is nothing, but you can, just visualize like how much is the difference in terms of the frequency of these words. Or when you're explaining, the behavior of your text data to some third person, you can use this kind of a visualization or graph so that the third person can easily understood that, okay, so this is how, the words are distributed in our data set, right? Rather than if you show this particular outcome to a third person, it's very difficult for a third person to understand from these numbers directly. But if you just show this visualization, anyone can easily understand, right? So it will help to understand what kind of information present in your data set. Like, so let's say a third person doesn't know what kind of a data set you are dealing with, but just by looking this particular visualization, anyone can say that the most of the things related to in your text document is related to COVID-19, coronavirus, food, store, people, grocery, these kind of things. And if you interrelate this, top 5 or top 6 terms in terms of the frequency, you can say that this is something, like getting the stocks related to groceries, or store the food items because of the COVID-19 issues, or the impact of COVID-19 over supermarket or shopping or online thing, or people get panic. So I mean, anyone can get a basic idea just by looking this graph without even seeing the data set, right? So this is something we are calling as a extracting the information from our data set. That is something called as a hidden information from our data set. Clear? Exactly, Kritika. This is the COVID data set, right? That's why we are getting most of the things related to COVID or coronavirus. Yes, Kritika. What does rotation is equal to 45 mean? Okay. So guys, if you see here, while getting the visualization, I have used something called as a rotation is equal to 45. So this is the like degree what I have used in a x ticks. So this is a 45 degree, and what it denotes. So if you see here, whatever values we have over the x-axis, these values are 45-degree inclined, right? If you don't use the 45-degree inclination, so it will be a straight one like this. So there will be overlap, between a couple of these labels. So just to avoid that overlap, what I have done, I've just tilted these what you can say levels, right? That's why I've used 45-degree inclination. If you use the 90-degree, it will be like this: COVID-19, coronavirus, food, vertical. Right? This is the meaning of This is the meaning of rotation is equal to 45-degree. Okay. Any other questions, guys? Anyone? YouTube guys? Anyone? Great. So I hope up to this point, everyone is clear. All right. Okay, let me show you some more details. So this word cloud is, I hope, clear to all of you. We have already covered this part in our past sessions. Okay, great. So let's see, guys, the part of the feature engineering. Feature engineering is nothing but, guys, when we are, manipulating our input features. So what is the manipulation is here? So we have done with the text data pre-processing part. Now the next part is applying the model. But I can't apply model directly over my clean text data. Right? So what I need to do? I need to transform this clean text data into its numerical equivalent. Since we are transforming our features, so that is something we are calling as a like feature engineering part. So this is a very famous term in the data science, feature engineering. So feature engineering is nothing but ultimately we are dealing with our features, we are manipulating our features, or sometimes we need to create new features based upon the existing features. So all of those things comes under the feature engineering part, right? So what here we are doing, we are just transforming our feature from text data to its vector equivalent. So for that, guys, what we are doing, we are using the TF-ID of vectorizer, right? And this is the same method. Okay, so just do one thing. Like you can ignore this part and go with this part, this one. So what we are doing here, we are creating, first of all, creating an instance of that TF-IDF vectorizer as a vectorizer underscore TF-IDF. Apply the fit underscore transform method over the corpus. So what is a corpus? Corpus is something clean data what we are getting after removing the stop words. If you see here, after removing the stop words, this is the last text data pre-processing step we have applied, and the output is something we got as the corpus. So corpus is a data set which contains our clean data. Over there, we have applied the TF-IDF vectorizer. All right. So up to this point, guys, we received vector representation of our clean text data. Now, after this, since we got the numerical, representation or vector representation of our text data, this particular matrix, this is the place after which we start building our model. Now, before going further, let's understand how we build the model and what are the other things are there. Right? But before that, let me show you one thing. If you see these two lines, line number 59 and 60, this is something, guys, after applying the TF-ID of vectorizer, what TF-ID will do? It will create a vector equivalent, and how it will create. So if you guys recall, we have already discussed this TF-ID of vectorizer in a detailed manner, how it works at the backend. We have two things, TF, term frequency, and IDF, right? So for each and every token, it will calculate the TF part, what is the term frequency, and what is the inverse document frequency. And the final TF-IDF value is nothing but TF multiplied by IDF. That is the final TF-IDF weight value. This is, it will do for each and every token. right? If you want to get what is the value created for each and every token, you can easily get it from, so under the TF-IDF, we have something called get feature names out. So it will show you what are the different tokens are there in this particular, what are the tokens are used by TF-IDF. And for each and every token, what is a TF-IDF vectorizer value, right? So this is what we are, just printing and converting into a data frame. So this is what we are getting the output. So you can see this is the head of this one. That means these are my top tokens. I mean, not top tokens, actually, these are the first couple of tokens from TF-IDF, and these are the values of these tokens. These are the numerical tokens, right? Since we haven't removed the numerical values. So that's why we are getting some numerical tokens. So what you can do, you can even remove these numerical values. These are of no use. Okay. So if you're interested, you can manipulate this code and go back to this pre-processing step, and you can remove the numerical values even. So this is the head of this particular data frame. If you see the tail of this data frame, now you can see there are, these are some character tokens are there, and these are the TF-IDF value for these tokens. So I mean, this is how you can check the token, even their TF-IDF value. And what is the shape of this matrix created by TF-IDF vectorizer? That is the 95672. So there will be two columns with the like feature and this vector with 9567. Okay, so this is basically this data frame size. So there are these many tokens, 9567 tokens with like their values. So I mean, this is how it will generate this vectorized vector equivalent form of the clean text data. Right? Clear, guys? This part. Now, can you guys tell me what is the what this TF value indicates and what this IDF value indicates? What this TF value indicates and what this IDF value indicates? Anyone? Text frequency for TF. Exactly. So TF is for the each and every token frequency. What is this IDF part? What is the meaning of this IDF part, guys? TF is the frequency of token. That's correct. Inverse document frequency. Lavanya, this is the full form of this IDF. What I'm asking, what this IDF indicates? Like TF indicates the frequency of token, which is the term frequency. IDF is the inverse document frequency. What it indicates? What about YouTube, guys? Number of times the token appears in all of the corpus for IDF. That is something you are taking a partial part from the formula one. That is a partial term we use in a formula of the IDF. Anyone else? What this IDF term indicates? Okay. So can anyone tell me how count vectorizer will generate the vector representation? Like how count vectorizer will generate the vector representation. For example, if you recall the binary weight method. So binary weight is one of the method, to do the vectorization, right? Binary weight. So how binary weight will generate this vectorization matrix? So either 0 or 1. So if the term is present in the document, the value will be 1. If the term is absent, the value will be 0. So like this is how it will generate this vector equivalent of the text data. So likewise, how count vectorizer will generate? Do you guys recall? Anyone? Exactly. Yes, Bipraj. Correct. So the number of times a particular token appears, right? Which is nothing but the frequency. So count vectorizer, how count vectorizer will generate this particular vector equivalent of this text data using the frequency of each and every token. The number of times a particular token appears in the document. This is what we have discussed, right? So what is the drawback of the count vectorizer? Do you guys recall the drawback of the count vectorizer? What about YouTube guys? So guys, the drawback of the count factorizer is it will only take care about the frequency term, like frequency for each and every token, but it will not consider how important this particular token is. Whether this token is important or not, it will just use the frequency to represent this token in the document. This is the drawback of the count vectorizer. Term importance is not considered. That is being overcome by TF-IDF vectorizer. So in TF-IDF vectorizer, we have two terms. One is a TF, term frequency, which is nothing but frequency of a token, just like this. Along with that, we have another term, inverse document frequency. This part will indicate how important the token is, how important the term or token is, which is being identified by IDF part. Then it will multiply these two numbers, and that is the final TF-IDF weight. Clear, guys? This concept? We have already discussed this part, right? So like this is how we are getting the TF-IDF vector representation. And there is one question, guys. Explain this bar graph code. So Divya, this is the bar graph we are plotting using this particular code. What is this code? So what we are using here, we are using something called as a matplotlib library. So let me just show you from the top. Yes. So here you can see, we are using the matplotlib library. Under the matplotlib, we have something called as a pyplot, Python plot. We are just importing this particular module as a PLT. Right? Matplotlib is one of the module in the Python to get the visualization or graphs. So from the matplotlib, you can get multiple graphs or the visualization, like you can plot the line chart, you can plot the scatter plot, even you can plot something called as this bar plot, histogram. These are the different graphs or visualization, right? Even you can plot violin plot. You can plot swarm plot. So likewise, we have a multiple plots you can, plot using the matplotlib. So it is one of the visualization library. We have another visualization library as a Seaborn. So both are the visualization library or packages. So here we are using the matplotlib.pyplot as a PLT, right? So let me just show you. Yeah. So what we are doing, first of all, we are fixing the size of this particular visualization. That means 15 unit over this x-axis and 7 unit over this height, right? So whatever this, this size of this figure you are seeing, that is based upon this particular units. You can change this unit if you want, a small graph or a large graph accordingly. Then under the PLT, we have a method called as a bar. You get a bar chart between X and Y. What is this X and Y? This X and Y is nothing but it is the word and its frequency. So if you see here, this is what we are getting, right? Each and every word with its frequency. So on the x-axis, we have this word. On the y-axis, we have this frequency part, right? So likewise, we have this x and y. And this GIF method is used actually to combine. Okay, so if you see this particular outcome, so the word is separate and this, frequency is separate. Just to map this one so that the COVID-19 is mapped to 1298 number. We use a zip method. It will just attach this, this number with this word. This is how we are getting X and Y. And then we are just using the bar plot for X and Y. So over the x-axis, we have all of the words, and y-axis, we have their frequency. And then X tick is nothing but whatever words it is showing over the x-axis, we are just providing the rotation of 45 degrees so that there won't be any overlap. And then plt.show is nothing but display the visualization. So 45 degree means, this 45 degree orientation for each and every word. Right? This is how we have this particular bar plot. Is that clear? Any questions, anyone? Okay, cool. Don't worry, guys. Attendance link will be there in some time. Don't worry about it. Okay. Okay, so let me share. So let's see, guys. Okay, up to this point, we have converted our text data into its numerical equivalent. Right? Apurva, if you have any question related to certificate part, you can ask it, to Amar at the end of session, right? So for the time being, please hold on your questions. Okay. Now see, guys, once we have, done with this vectorization part, then let's understand how we can build the model. So for model building, guys, we need to follow a couple of steps. What is the step? So first of all, whatever is the data over which we want to build a model. So here, what is the data? The output of the TF-IDF. TF-IDF output is the final data, TF-IDF output. So whatever this matrix we are getting, this is the final data over which we want to build the model. Right? So this is the values of this particular matrix, right? You can see here. Now what we do, guys, we just split this data into two data sets. So it's like one is a train data set. We call it as a train. Another one is a test data set. Train data and test data. Right? So in that way, we have these two data. And what we do, we provide most of the data points in the train data. So it's like, let's say, out of all the data, let's say 80% data we provide over this train data, 20% over the test data. Or we can also do like 70% over the train data, 30% over the text data. So I mean, in that way, you can choose any of this, percentage, but most of the percentage of data over the train data only. Then, so this is the first step. Second step is we build our model over the train data. Build model over train data. So why we build the model over the train data? Because most of the data points are present over the train data only. So we build the model over the train data. Once our model is ready, then the third step is how you will know the model is good or bad. So until unless you apply the model over some test data, you won't get an idea, right? So what we do, we test our model, test model. So where we test over text data, over this text data, over text data. So we check how this model will perform over the text data. So like this is how we follow the steps. I'm not getting into too much technical details, but yeah, this like generally we follow this kind of a approach. Okay. Guys, attendance link is there. You can mark your attendance, right? So this is how, guys, we are getting the train data and the text data like this one. So we have already imported a method called train test split. And then we have just separated our X and Y variable. Y is our class variable, right? And this is the place where we can provide what is our text size, which is the percentage. So what is the text size here? I have taken 33% over the text data. And whatever is left, that is over the train data. Right? Can you guys tell me how much percentage is there in the train data? If 33% is in the text data, how much is in the train data? If I have a 33% data in the text data, then how much is on the train data? It's a 67, right? 67%. So this is how we are doing the splitting, but you can also do like 70:30 or 80:20 or 75:25. You can choose any of this ratio, but make sure most of the data over the train data only. So like this is how we are getting the X train and Y train. That means the X variable, which is the tweet data of train data set, and class variable of the train data set. Same, the tweet data of the text data set and class variable of the text data set. So likewise, we are generating these 4 data sets. Right? And the next part is building the model. So here, guys, I have selected 2 models. So there is one of the model called as a logistic regression. Let me remind you what we are doing. We are building a text classification model. Text classification model. What this model will do, it will classify each and every input tweet. Either this tweet belongs to class 0, class 1, or class 2. Now, what is this 0, 1, 2? These are the sentiments. So 0 means the user has neutral sentiment. 1 means positive sentiment. 2 means negative sentiment. So this is what we want to perform. So if we want to build a classification model which will classify each and every record into one of these categories or classes, then we have a couple of models available. But here we are going to discuss something called as a logistic regression is one of the model what we have, which will perform the similar task, right? Another model what we are going to build is a naive Bayes. So these are the name of the different models what we are going to build, right? Now, how to build is basically we build the model using the fit method. Fit is a method what we use to apply our model over the trained data. So this is the place where we build the model over the trained data. And to test our model, we use the method called predict. Predict over the text data. So, this is how we have just explained. Fit the model, that means train the model over the trained data, build the model over the trained data, and test the model over the test data. So how we build the model? Using the fit method. How we test our model? Using the predict method, right? So logistic regression is one of the model which will do the classification kind of a task, right? So what we are doing, we have already imported this logistic regression model. So we are just, creating an instance or initializing this logistic regression model and then applying the fit method over training data. So like X train and Y train. This X train contains the tweets, Y train contains the class, right? And then once our model is built, so this is something we are calling as a model building. Once our model is built, we are testing my model over the text data. So the name of the model is something we are providing LR_model, logistic regression underscore model. And then we are using predict method to get the prediction over the text data, right? What prediction it will do? So for all the tweets in the text data, it will generate or it will predict the class, either 0, 1, 2. And for the text data, we already have actual classes as a Y test. So we got the prediction classes and the actual class. Then based upon the comparison between these two, we can get the accuracy, how much accurate our model. So you can see here, we are using something called as the accuracy underscore score method. And between the Y test, which is the actual class of the text data, and this is the predicted class of my text data, Y pred. And the accuracy is a 60%. 0.60 is nothing but 60%. So this particular model is 60% accurate to get the prediction over my text data. Guys, attendance link is there. You can mark your attendance like. So this is how, guys, we can build a logistic regression model. And you can check the model accuracy as a 60%. Similarly, we can also build something called as a naive-based model. It is also classification model. It is also one of the classification model. Right? It can also classify each and every input data into one of the classes. So under the naive base, guys, we have two methods. One is a Gaussian naive base. Another one is a multinomial naive base. NB stands for the naive base. You can use any one of them. So here I'm showing, applying both of these methods, and you can see the accuracy. So this is how we are just initializing this Gaussian naive base method, right? And fit this model over the trained data, do the prediction over the text data, and check the accuracy, right? So the accuracy of the Gaussian naive Bayes model is a 47.2%. Right? And the similar way, if you apply multinomial naive Bayes, so just initiate this particular model, create an instance, and then apply the fit method over the trained data, predict over the text data, compare the actual class of the text data as well as the predicted class, and get the accuracy as a 47.8%. So if I just summarize you, we have applied three models. One is the logistic regression. Let's say LR. This logistic regression model provides me the accuracy as 60%. Then we have used Gaussian naive Bayes, which provides accuracy as a 47.2%. Then we have used multinomial naive Bayes, which provides accuracy as a 47.8%. So what do you think, guys? Out of these three models, which is the best model based upon the accuracy? Out of these three models, logistic regression, Gaussian Bayes, multinomial naive Bayes. Exactly, logistic regression, right? Let me also check with YouTube. Okay, yes, correct. Our Kamlesh link is there in the chat box. Please check your chat box. Attendance link is shared multiple times, guys, in the chat box. Please check your chat box. Okay, yeah, correct, guys. So logistic regression is having the highest accuracy compared to other models. So what we can do, in the final prediction, I will be using the logistic regression as my final model, right? Since the accuracy is highest. So I mean, in that way, we can build the model. And in future, if I will get any of the tweet, I will directly pass the tweet in this LR model.predict method. And I will get the prediction. For example, let me just show you. For example, let me just pick one of the tweet. Okay, let me just pick it from here. Let's say this is what we are getting as a tweet. This, let's say this one. Or let's say this one, this part. Okay, let's suppose this is what we are getting as a tweet in the future, right? So what I will do, I will use the same model like LR underscore model dot predict. And within that, what I can do, I can pass my input tweet, right? And if you just run it, I'm not sure whether I've run this part. Okay, yeah. So if you just run it, okay, so basically, okay, so basically it is looking for a data frame kind of thing, like in this format, right? So it will not take the individual tweet, but yeah, in future, if you get tweets like in form of the data set, so you can directly pass that data set here and then get the prediction. All right. So like this is how we can build a text classification model. So this model I have showed you in this exercise, I have showed you neat text is one of the package which is very important, a very powerful package when it comes to the text data preprocessing. Then I have showed you again the vectorization concept. And then logistic regression, Gaussian naive Bayes, and multinomial naive Bayes model for a classification purpose. All right. So this is what, guys, I have for today's session. And all of this, data set and code files is there over the LMS part. You can go there and download this, right? So any questions, guys, for me? Anyone? Okay, guys. So if you don't have any questions for me, over to Amar.
Yeah, sure. Thank you. So, dear participant, I have an announcement from my side. So, we given you the drive access. Okay, drive access means on the LMS we uploaded all the material and which is uploaded in the drive. So you can download that material. Please, I'm requesting don't share the editor request. Okay, it will get a multiple request. So you have to just click on that link. It will take you through the drive. You have to download that material and you have to use. Okay. So coming to the attendance point, I'm sharing the attendance link once again. So please mark your attendance. And if you have any query or question for me, let me know in the chat box. Where is the link to download the file? So you will get that link over the LMS. So do we get it for excellence to approve? What's the question? Is the certificate of only for participation? Yes. So we have surprise tests. So those who are going to do a top 10, they will get the two certificates, certificate of appreciation and a certificate of participation as well. And for all those who are going to complete their attendance 60 and more than 60%, they will receive the certificate of participation. Okay. Is our attendance is valid for through this link, or can we log in LMS site at the attendance? You can mark your attendance using any platform. It should be with Zoom, it should be LMS, or else YouTube. There is no integrate. So I have registered, but the Zoom link is not coming. So for an you're on Zoom only, no? Test will be conducted before or after the training. Yes, you think your question is right. How we conduct test before the training? On the agenda, you know that what question we are going to ask. So it will be taken once we are done with the all portion. Okay. Sir, actually from last 2 days, I am listening a class, but at the end of the session, power off, and I can't able to fill a form of attendance. Yeah, so there is no any another option to fill the attendance form again and again, as it is to close on the same day. So extremely sorry for that. Yes, guys, I'm sharing the attendance link once again. You to participant, any query? I didn't receive the day file link through the WhatsApp. Okay, but we mentioned that on the day 4 also, the Zoom link is same for all the days. So, guys, don't give the reason. If you have to join, there are multiple ways to join. When I get the certificate, so once we complete the training program, after the 7 8 working days, you will receive the certificate. If your attendance is more than 60%, can I leave now? Yes, guys, if we don't have any query or question, you can leave for the day and we'll meet you on tomorrow at same time. So Surya, drop an email to edl@xla.com. How much attendance is required to get the certificate of participation? So 60%. Yes, someone is telling. You're welcome. Guys, are you enjoying the session? Thank you, sir. You're welcome. Thanks, sir. I think I know because, sir, I have ever provided my resume until when I was the maybe till I remember. Okay, so no. Sir, I don't remember my email ID. Which can I mark attendance? What to do? So just at the time of marking your attendance, you are able to see there by which email you are marking your attendance. Okay, so no need to worry about that. Yes, guys, if you don't have any query or question, you can leave for the day. We'll meet you on tomorrow. Let me check the comments from the YouTube as well. Sir, can you please repeat the criteria for getting the certificate of appreciation? So, certificate of appreciation is valid to those who are going to do a top in the test. There will be surprise test. The top 10 members will get the certificate of appreciation. Okay. Sir, please send the attendance link. Sir, if any other session after, kindly ping us. Definitely on the last day of this training program, we'll come up with the one more training program. And on that day, for sure, I will share all the information. Okay. Can we get the certificate through mail or other? Yes, definitely via mail. Mahesh Satpude. Thank you, sir. Bye. Yes, bye, guys. Guys, any unique question? Sir, what's up about the day filing or class we didn't get the notified through the WhatsApp group? Okay, sorry for that. Last class attendance link. Last class attendance link is closed on the last class only. Attendance link, yes, sure, Dr. N. Umadevi. I'm sharing the link. Surya, for which email ID should I message, sir? Drop an email to edl@xlr.com. Let me check the comment over the YouTube. Good evening, sir. Good night, sir. कहना क्या चाहते हो? Good night, good night. Thank you, sir. You're welcome, ma'am. Okay, so guys, I hope there is no such more questions. So done for the day. I hope you enjoy the session and you're enjoying and you will be enjoyed till the last day. So it's time to say a bye and we'll meet you on tomorrow. When I used to say na, be like, it's time to say the bye. I have a couple of the questions. So is there are no class conducted on 24th? 24th is a Sunday. We don't have classes on weekend. Why we are giving the off on the weekend, na guys? For a practice purpose. How to get the certificate of cloud and DevOps course. So Ankit, you will get that via email. Thanks, sir. You're welcome. Guys, can we wind up? Out of 142 participants over Zoom, if I got the 4 response, then definitely we wind up. Guys, don't be a selfish. Huh? You are be like, can I leave, sir? But you don't are going to say you're like, sir. Okay, sir, we'll wind up for the day. Huh? I'm kidding, guys. Don't worry. Okay. I know that you're getting extra learning by sitting here for 2 hours. Need a little bit fun as well. You're agreeing on my point. At least type it down here. Thank you. Yes or no. Yes, sir. No, sir. Okay. Thank you so much for your response.